So going over this little practice paper we've got here, okay, it says 3x to the power of 3. That essentially means, let's go with something basic. What does this mean? It means x times x times x. Now, in this scenario, it's 3x, the whole thing cubed. That means we're going to go 3x times 3x times 3x. That's what this means. It's whatever that's in the brackets going to be multiplied by itself 3 times. So in this scenario, x cubed means x times x times x. 3x cubed essentially just means 3x times 3x times 3x. So where is that? It's definitely not this one, because that's x times x times x. It's not B, because that's just 3 times x times x. Now, can it be C? So if we were to break this up, it just basically means 3 times 3 times x times x times x. I've just taken it apart. Why? Because between the x's, we've got times. So that is your answer, okay? So the answer is going to be C. Okay, it says expanded form. Next question here. It says 2x to the power of 7 is times 7x cubed is equivalent to. So what we're going to do is we're just going to break this apart. So we're going to go 2x, I'm just going to write this again, 7x cubed. Okay, cool. Can I multiply these bases? Yes. What's that equal to? 2 times 7. And then times x to the power of 7 times x to the power of 3. So 2 times 7 is going to be 14. Then times x to the power of 7 times x to the power of 3. Are they the same base? Yes, they are. So which index law? It's going to be the first index law. And what are we going to do? We're going to go 7 plus 3, which is going to be 14x to the power of 10. We add the powers. Okay, so you just need to be aware of that. A lot of people that go, oh yeah, 7 plus 2 is going to be 9. So it's going to be 9x to the power of 10. No, we do not add the bases, we add the powers. Okay, so that's going to be this part here. B is your answer. I'm going to put up the next question here. Okay, and that's going to be going over 2 to the power of 12. Oh, divide that by 2 to the power of 7. So this is going back to the second law of indices. Okay, when you divide with the same base, you're going to subtract. So when you see a question written in this form, what you want to do is you want to write it in a fraction form. Okay, what are we going to do now? We're going to subtract the powers. Where's the higher power? It's at the denominator, the bottom. So, sorry, the higher power is going to be at the top. So it's the numerator. So we're going to do 2 to the power of 12, take away 7, which is going to be 2 to the power of 5. Now, I don't have 2 to the power of 5. What the hell does 2 to the power of 5 mean? It does not mean 2 times 5, which is 10. No. So that is not your answer. 2 to the power of 5 means 2 times 2 times 2 times 2. What's that? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So your multiplication should be really, really good. Let's go to this question here. So now, this is the next law of indices. Okay, so when you're raising powers, but what's the weird thing here? It's in a fraction, okay? So, let's say for example, you had 4 squared. What does that mean? It actually means 1's there, you're gonna have 4 to the power of 1 times 2, which is 4 to the power of 2, which is 16. Okay, but we have a fraction, okay? What do we have? We've got 4 over 9 whole thing squared. What do we say is the first rule? Okay, this is a big hint. Put a 1 there. It doesn't take that long to do that. A lot of people forget that and go, oh yeah, 4 times 2 is 8, 9 times 2 is 18. No, that's not the case. So here you've got 4 to the power of 1 times 2, divide that by 9 to the power of 1 times 2. Then when you simplify, 4 to the power of 2 9 to the power of 2, and that's going to be 4 to the power of 2 means 4 times 4 is 16. 9 to the power of 2 means 9 times 9, which is 81. So your answer is going to be 16 over 81. So some people might go, oh yeah, that's 4 times 2 is 8, 9 times 2 is 18, 8 over 18. They may select this. That's why this particular answer is there, to trick you, okay? This means 4 squared over 9 squared. So how we avoid that issue is by putting the power 1 there, okay? So that's how you approach that question. Always, whenever you don't see a power for a base, chuck a 1. Okay, yeah, people might go, oh no, that's a bit too babyish. I'm not gonna do that, but do it, okay? Because that's how you're gonna avoid making any form of errors.